Hello everybody, and today we're going to start on chapter 12 or 12.1, okay, the derivative and its basic rules. So basically what we're studying is something called calculus. It's a branch of mathematics that is quite famously invented by Isaac Newton and also at the same time by Leibniz. So in calculus, it provides us tools, okay, and methods for calculating things like the rates of change and like for example finding the gradient of a tangent or calculating the instantaneous velocity of a moving object and finding the maximum and minimum values of a variable quantity. So in this chapter is the very basics, right, of calculus. So we will be introduced to what differentiation is and actually how to go about doing differentiation. So for example, calculus gives us a tool, right, to find the changing speed of a rocket. Okay, now, so in this chapter 12.1, you learn how to relate the derivative of a function to the gradient of a tangent. So use standard notations to denote a derivative and find the derivative of x to the power of n for any rational value of n. So now, we are quite familiar with the gradient of a straight line. So if you find a gradient of a straight line, you know that it is constant. Anywhere on a straight line, you know that you will have the same gradient. But if you look into a quadratic curve, okay, such as these two examples here. So for example, down here, if you were to have to ask, how do I find the gradient at this point? Okay, so at this point, what we have learned in elementary mathematics is to actually draw a tangent. We find that hey, at this point of the curve, there is a certain gradient. If I say at P, similarly at P itself, there will be another value. Then this will actually give you, okay, if you draw a tangent there, you can actually find the gradient at that point itself. Hence, in this such fashion, you find that for a given function, if it's non-linear, okay, not straight line, there'll be different values of the gradient at different points of the function itself. So today we're going to learn about the power rule. Okay, first and foremost, we want to find the derivative for certain functions itself. So for example, the derivative of y equals to x to the power negative 3 is negative 3x to the power negative 4. The derivative, okay, or you differentiate y with respect to x, okay, what you get is negative 2x minus 3. So what I'm going to do now is to show you this thing called the power rule and how we can actually do it. So now this is found in your textbook itself. So it tell you that where n is a rational constant, okay, then the when you differentiate y, okay, how to read this is when you differentiate y with respect to x. Okay, that's what it means. So now what we have here is this. We have y equals to x to the power of 50. So now the very beginnings of calculus. If I want to differentiate y with respect to x, the power rule will be this. The power, you just bring it down, 50x. Then what you do is you minus 1 from the power. So for part A, you differentiate y with respect to x, you get 50x to the power of 49. For part B, okay, you cannot do this directly. So what I can do is this, we express it in a form that is useful to us. So 1 over x to the power of 10 can be expressed as x to the power of negative 10. This is something that we have learned in indices in secondary 3 EMATS, I believe. So you differentiate y with respect to x, same thing, negative 10, you bring down the power. So you have x, negative 10, similar to what we did above, you minus 1. So it's negative 10 to the power x to the power of negative 11. That is it, okay, it's not super difficult. Alright, so now why don't you try it now and then I will help you out in a bit. So this is try 1. Differentiate y with respect to x for y equals to x to the power 20 and y equals to x to the power of 40. And I'll start going through these two in 3, 2, 1. Okay, let's go. if y equals x to the power of 20, you differentiate y with respect to x is 20x to the power of 20 minus 1. If you get 20x to the power of 19. If you don't want to skip this step and directly write this step, please be my guest. Similarly, for part B, y equals to x to the power of negative 40. I start to differentiate y with respect to x. You get negative 40 x to the power of negative 40 minus 1. So it's negative 40 x to the power of negative 41. Okay, now a constant multiple rule, okay, and the constant rule itself. For constant multiple rule, let me just show you what it means. Basically, instead of, for example, what we have is y equals to x to the power of 5. If you differentiate y with respect to x, you get 5x to the power of 4. What happens if you have y equals to 7x to the power of 5? So the constant multiple will be, how do we deal with this 7? Actually, it's quite simple, not to worry. And for the constant rule is this: when you differentiate a constant, okay, that means a number, okay, it becomes the 0. Okay, now let's just give you a few examples to get us all on the same page. Now, for first one, I'm going to use the constant multiple rule. If y is equals to 7, x to the power of negative 3, we differentiate y with respect to x. Again, what we do with the power here, okay, we will bring it down, negative 3. The constant multiple is 7, just leave 7 there, x minus 3, and we minus 1. Just like what we've been doing in the previous questions. So in this case, I get negative 21, x to the power of negative 4. Okay, similarly for part B, what we need to do is to first, I think, re-express this into something that's more useful to us. So if you remember, cube root like this can actually be re-expressed as to the power of 1/3. So down here, what we're going to do is x squared to the power of 1/3. What happens here is I get 4 over 3. If you resolve the brackets, what you get is x to the power of 2/3, like this. So now what we're going to do here is this: if I differentiate y with respect to x, I have 2/3, I multiply to the constant multiple there, 4, 3, x, 2/3, once again, I minus 1. So what I should get here is 2 times 4, so I get 8 over 9, x to the power of negative 1/3. Now you try 2. Pause the video for a bit, okay, give it a shot. I don't think it's super difficult, and I will assist you in 3, 2, 1, let's go. Okay, given that y equals to 8x to the power of negative 5, you differentiate y with respect to x, negative 5, the power comes down, you multiply to the 8 minus 5 minus 1. So what I will get is negative 40x to the power of negative 6. Part B, once again, if you must remember, square root actually becomes power half. So I re-express y as 2/3 x to the power of 3 over 2. If I differentiate y with respect to x, 3 over 2 comes down, 2/3 x to the power of 3 over 2 minus 1. So what I get is x to the power of half. And that's it for try 2. Now let's move on to example 3. So example 3, again, once again, y is equals to 1, 2, 1x. If I differentiate y with respect to x, you note there's a 1 here. So if I bring down 1 times 1 to 1, it still is 1. So I get 1 times 1 to 1, x to the power of 1 minus 1. So what I get is 1 to 1, x to the power of 0, I get 1 to 1. So basically what this is saying is this: if my y is 7x, dy dx is equals to 7. If my y is equals to 100x, you differentiate y with respect to x, you get 100. If my y is negative 700x, differentiating y with respect to x gives me negative 700. I think you should get the picture by now. I will erase all of this. Part B, y equals to 6. I will just show you the... So y equals to 6 can be rewritten as x to the power of 0. So you differentiate y with respect to x, 0, times the x to the power of 0 minus 1. 0 times 6 just gives you 0 straight away, so it becomes 0. So in short, okay, just to avoid confusion, it basically means this: if y equals to 6, 6 being a constant, differentiating y with respect to x is equals to 0. Okay, and it works for all the other numbers. What do I mean? So if you have y equals to 1000, so you differentiate y with respect to x, you get 0. If y is negative 700, differentiating y with respect to x will give you 0. And that is what you should be able to observe from this. So for try 3, give it a short moment and I will assist you shortly. And we will go in 3, 2, 1. Okay, given that y is equal to 1.001x, find dy dx. Based on what we have learned in the previous slide, differentiating y with respect to x will just give you 1.001. Similarly, for part B, notice that 99 root 3 is a constant, so immediately you should be able to write that the differentiating y with respect to x gives you 0. Okay, sum rule and the difference rule is this: if you are differentiating a function and there are many different parts, you can actually do them one term by one term. Okay, what do I mean? For example, if you look at part A, this is one term, this is one term, this is one term. So, if I were to do differentiating y with respect to x, you just deal with each of them separately. So what we have is 3 over 2 times the 2/3 x to the power of 3 over 2 minus 1 gives me half, plus 3 times root x is actually x to the power of half. So what I'll get is half, okay, times 3 x to the power of half minus 1. So it is negative half. You differentiate negative 5x, you will get negative 5. Hence, for part A, what you get is x to the power of half plus 3 over 2 x to the power of negative half minus 5. Okay, it is similar for part B as well. So for part B, what will be happening here is this. First, I will express it as something that's easier for me to work with. 4x to the power of negative 3 plus 1/4 x cubed minus 4. If I differentiate y with respect to x, I work on each term separately. Negative 3 times 4 gives me negative 12 x to the power of negative 4. This term 3 times 1/4, I'll get 3/4 x squared. Minus 4, you differentiate it, it's a constant, you get 0. So that's it for part B. We move on to try 4. Pause the video for a short moment. Then once you're ready, please unpause the video and I will help you with this try 4. Okay, for try 4, there's something that's a bit different. We have been working with y so far. So what happens if they express a function here as fx? So not to worry. I give you an analogy. If y is equals to x squared, then dy dx is equals to 2x. This we are familiar with. So similarly, excuse me, if fx is equal to x squared, the first differential is 2x. These two are the same ways. That's how we actually express them. They are actually the same thing, notation wise. So therefore, if fx so the first differential is 10 x to the power 4 plus 6 x to the power negative 4 plus 0. Part B slightly tricky, but we can still work on it. Okay, what we can do is we express it as separate terms. Okay, then what we can do is we eliminate, so it's half x minus 3 over 2 plus 7 over 2 x to the power of negative 1. Then we find the first differential, gives you half 0 minus 7 over 2 x minus 2. So I write it nicely. And that is it for try 4. Example 5. Okay, so far I've not really spoken about what the differentiating y with respect to x gives us. Actually, when you find that when you differentiate y with respect to x, you are getting a expression that helps you to find the gradient at any given point of a graph. Okay, so or a function. So let me just help you here first. So now, if you notice, we have a curve that is given by y equals to 6 minus 4x over x. So slowly, first and foremost, what I do for part 1 is this. Y is equals to 6 over x minus 4x over x. Y is 6x to the power negative 1 minus 4. Okay, now, if I differentiate y with respect to x, what I get is negative 6x minus 2. Or it can be written nicely as negative 6 over x squared. Okay. How this actually helps me in calculus, because we are saying that calculus actually helps us to find the rate of change, helps us to find the gradient. So now notice at point A, the x value is 3. The y value is negative 2. We ignore the y value for now. All we need is the x value of 3. How calculus actually helps us is this. First, alright, dy dx, x equals to 3. So basically, what this notation does for me is, I am saying that I am substituting the value of x equals to 3 into my differential of me differentiating y with respect to x, which is this negative 6 over x squared. So what I get is negative 6 over 3 squared is equals to negative 6 over 9 is negative 2/3. What this means is that at this point of this graph here, if I were to draw a tangent, okay, at that point there, okay, you will find that the gradient of this tangent is equals to negative 2/3. This is the meaning of using the first differential, okay, to get the gradient of a point on the graph itself. So therefore, if we are now going to look at the point, find the gradient of the curve where y equals to negative 10. So once again, we just note down previously that my differentiating y with respect to x is negative 6 over x squared. So now, if y equals to negative 10, I still need the x value to find the gradient because it works with the x value, dy dx. So now, when y equals to negative 10, I substitute it into this equation here. So when y equals to negative 10 is equals to 6 minus 4x over x. Why I'm doing this is because I would like to obtain the relevant x value. So if I start to solve, I find that my x value is equals to negative 1. So if my x value is negative 1, all that needs to be done is dy dx, okay, when my x value equals to negative 1, negative 6 over negative 1 square. I will get negative 6. So what this means is that at this point, when y equals to negative 10, my x value is negative 1. Okay, so if my x value is negative 1, okay, I think the curve is somewhere there. Okay, negative 1. Y equals to negative 10. Okay, so what happens here is this, I'll get the gradient of the curve to be, at that point there, to be negative 6 itself. So now, okay, please try 5 and I'll help you out in a short moment. Okay, for try 5 it is this, find the gradient of the curve at the point 2, 13 and the point where the curve meets the line y equals to negative x. So now, if I differentiate y with respect to x, I will get this. So at a, when x equals to 2, I substitute in the value of x equals to 2 into my differentiating y with respect to x, I'll find 11.5. That means that the gradient of the curve at this point is 11.5. Similarly, for part 2, okay, they say find the gradient of the curve at the point where the curve meets the line y equals to negative x. So I have to solve these two as simultaneous equations. Then I find that at this point the x value is negative 1. So if I substitute my x equals negative 1 into dy dx, I will find that my gradient is negative 8. Hence, the gradient of the curve at the point where it meets y equals negative x is negative 8. And that's about it for 12.1. Thank you.